Chapter 7 about precipitation. Precipitation in meteorology refers to all forms of liquid or solid water particles that form in the atmosphere and then fall to the Earth's surface. Types of precipitation include hail, sleet, snow, rain, and drizzle. Frost and dew are not classified as precipitation because they form directly on solid surfaces. The formation. The formation of precipitation may occur at temperatures above or below freezing. Precipitation that is formed in temperatures entirely above freezing is called warm precipitation. Cold precipitation, on the other hand, involves ice at some stage of the process. Let us understand these in more detail. Warm precipitation. Nearly all precipitation begins with the condensation of water vapor above particles in the air called cloud condensation nuclei. Sea salt particles left behind when sea spray evaporates are particularly effective nuclei. Saturation of air occurs when rising air currents cool without loss of heat by expansion. Because the saturation of water pressure of water decreases exponentially with decreasing temperature, cooling of moist air mass by lifting is an effective mechanism for producing saturation and condensation. Cold precipitation. When collision and combination are effective means for producing precipitation in the warm, humid, tropical regions, the formation of precipitation in middle latitudes usually involves ice. Because the vapor pressure at saturation is less over ice than over water, ice crystals will grow at the expense of water drops when both exist together in a supercooled cloud, which contains liquid drops at temperature below freezing point. This mechanism is a very efficient way to grow ice crystals to a size big enough to fall to the surface. Although most precipitation in middle latitudes begin as snow, at altitudes above freezing level, the form of precipitation when it reaches the surface depends on the air temperature structure. If the temperature near the ground is warm enough, the snow has time to melt and reaches the ground as rain. Hail occurs when alternating strong updrafts and downdrafts cause ice crystals to pass repeatedly through layers that contain supercooled water. The frequent passage through these layers allow the water to freeze around the growing hailstone and to accumulate in one layer after another. The geographical distribution. Because the annual distribution of precipitation depends on small-scale factors such as average global circulations, the geographic distribution of precipitation is not simple. In general, the average rising branch of the general circulation that occurs at altitudes between 15 degrees south and 15 degrees north result in heavy equatorial rainfall. Sinking motion occurs on the average over a band approximately 15 degrees of latitude wide-centered at 30 degrees north and south, and rainfall is at a minimum near these latitudes. A second rainfall maximum occurs between 40 degrees and 50 degrees latitude because of the high frequency of traveling cyclones there. Finally, the annual precipitation drops off sharply towards both poles because the cold air cannot contain enough moisture for heavy precipitation. Understanding the process of precipitation is one of the most complex processes of weather forecast. This chapter brings us to the end of section 2. We have now explored the different variables that are affecting the weather of a region. These variables play their own specific part in affecting the weather on a daily basis and climate at large. We will now move on to learn more about weather forecasting at large and its influence in the world at large.